Now, we can see how parallel streams greatly increase the processing power of your application. All right? But of course, as with anything, there is a cost. Okay? There is a cost in that it's another thing you have to consider. Right? Things can go wrong. And when things go wrong with parallel streams, they can go catastrophically wrong. Okay? So, what we need to do is, particularly when it comes to streams, all right? So, parallel streams is using all of the available threads that will operate on the stream, okay? An ordinary stream only has one thread, whereas a parallel stream will use all the available threads. Simple as that. Now, it won't hog the system completely. It's just as if there's 15 threads available, it'll use them. If they're not, it won't use them. All right? So that's the way it operates. But in effect, it does use all available threads. So in my case, 16. In your case, 4. If it's only a single core machine, then it'll only operate as 1. That's where you often see in minimum specs machine, it'll say you have to have a dual core because it's set up in such a way it can only work with 8 streams or something like that. All right? Now, so first thing we need to do, so the rest of this section is going to be all with dealing with parallel streams, all right, and making sure that you get the right, correct answers from your parallel stream, okay? So next one is going to be static void ex6, okay, and this is understanding independent operations. Now, what's an independent operation? So the results of an operation on one element of a stream should not impact the results of another element of the stream. Now, I have an example here, but I don't think it's a great example, but I'll put it in anyway. Okay. Now, I'm going to create a list of animals. This string animals is equal to new array list. Inside here, arrays as list. I'm going to say baboon, chimpanzee, anteater, giraffe, and elephant. Now, so I am going to use a parallel stream, and what I'm going to do in the parallel stream is that I'm going to change everyone to an uppercase version, and it's going to print it off. All right. So we go animals dot parallel stream dot. Now I'm going to map. So map is usually for taking one object and changing it to something else. All right, it's not a flat map either, by the way. So a map takes it's a lowercase map. Now, map takes a function. Function is it takes in an object to return an object. It can be the same type of object. In this case, it is. Right? So what does it take in? It takes in the string. And what it returns is the string, an uppercase version of it. 2 uppercase. Okay. And then I go for each. And I just print them out. Now, I am going to print out this. So, examples EX6. Right, so now the important thing to note here is that as it's a parallel stream, you can't predict order. All right, so as it's a parallel stream, in actual fact, what's actually happening is that all 5 of these are being processed at the same time. Okay, because I want to see how many streams or threads are being used, or potential threads that can be used. Go down here. Only 6 threads have been used. 1, 2, 3, 4, 5. Yeah, that's right. Because we've got 5 strings. A thread is going to be, we're going to have a task that's going to do each one of those things, plus the system thread. So we get an amount of 6. Is that okay? Now, when you have 16 as well, by the way, that is 15 of your own in one system thread. All right, do we all understand that? It's not 17, it's 16. Now, that includes a system thread as well. Okay, now, in your case, what does it say in yours? 4? Okay. In my case, it usually says 6. Now, you're not guaranteed it's always going to say 6. All right, there could be other times, let's say you have a lot of other applications open. It's hogging the system. And this is low priority. So it could read 3 in your case. It could read 5 in my case. But more often than not, it is going to read 6. Okay?
Say we got 4. One of those
is the system.
Going to be the system.
Yeah.
Thread, yeah? But that has priority obviously all the time.
Yeah. Yeah, it does.
Wherever it's given to, it can stay there all the way.
Yeah.
Through.
System thread is priority, but you can sleep it. So when you sleep it, the other ones can do their thing.
Yeah, yeah.
Okay? So yeah, system thread is always going to get priority. Now you can set priority threads. It's not on the exam as far as I can remember. Or I haven't looked at the next section yet, but as far as I can remember, you don't have to set priority threads anymore. Just as well because they're a pain in the arse to use. All right, now, so let's put in here, this is the sprint. Now, and I'm going to say here, you are not guaranteed any order when using parallel streams. So all strings could be acted upon at the same time. Okay. Now, the important thing to note is each of these strings are totally independent of each other. Okay, they are not dependent on each other. All right, so one object doesn't depend on another object. They're just a collection of objects. Now, if you had some dependency going on between all of the objects, then you're going to get all sorts of weird ass results. Okay? You're going to get all sorts of weird ass results. Now, the one I can think of is, which I haven't done out. Let's say you have a stream that creates, oops, hold on. The PC settings. Set up. Right. Okay. Now, let's say you have a stream that produces 5 dogs. Okay. And in the stream, you're going to assign an ID to each one of those dogs. And the IDs is going to be 1, 2, 3, 4, 5. All right. Now, and we want them stored in that order. Okay. Now, if you have an order stream, no problem doing that. It just increments the ID of the dog by 1 each time. Okay. Now, we're not using the dog class itself to assign these. We're using the stream to assign these values. Yes. So with 5 dogs, this is the ID, and we're using the stream itself to assign the ID. All right. The easiest one to use would be iterate. All right. Great. So 1, 2, 3, 4, 5. Everything fine. Now, as long as it's the stream, there's no problem doing that. However, and we want them stored, dog 1 and dog 2 and dog 3 and dog 4 and dog 5. Okay, that's the order we want them stored in, say, an array list. All right. Now, if you use a parallel stream to do that, yes, you will still have 5 dogs. More than likely, it will go from 1 to 5, but they won't be stored in any particular order. All right. You could have dog with an ID of 2 being first, dog with an ID of 3 being second. All right. They will be all over the place. All right. Because the stream, dependent on the ID of the first dog, that's going to say what the ID of the second dog is. Depending on the dog, the ID of the second dog, that's going to be the ID of the third dog. Depending on the ID of the third dog, that's going to be the ID of the fourth dog. Okay. If you have a parallel stream, that's just incrementing each time. You can have no idea what dogs are going to be placed where on the list. That's what I mean by independent operators. Okay. There's no connection between the two of them. Now, this example I've done here isn't great, but I'll show you the example. At lunch, I'll try and do a better example. I intended to do a better example this morning, but I forgot my laptop and I had to drive home to get my laptop. Okay. So apologies for that. All right. Now, independent operations basically mean that each one of the elements are independent in the stream. All right. And if you're saving them to, let's say, an array list, if you're saving them to a set, all right, that nothing is happening in the stream. So whatever happens to dog 1 is not going to affect dog 2. Whatever the stream does to dog 2, it's not going to affect dog 3. Whatever happens to dog 3 is not going to affect dog 4. Whatever happens to dog 4 in the stream is not going to affect dog 5. It shouldn't. Okay? They should be independent of one another. All right? If they're a stream, it's not so bad. All right? However, if there's a parallel stream, you have no idea what results you're going to get. And more often, it's not so much you don't know what's going to be produced, is you're not going to know their order.
You don't know.
Yep.
Say if you have some kind of a stash variable count,
Mm-hmm.
then it goes all over the place.
It will go all over the place, yeah. It will.
parallel streams would be able to handle that now.
It can handle it, yeah, but it won't display 1, 2, 3, 4, 5. It could display 4, 6, 4, 3, 2, 1, 5, something like that.
So the idea was based on the static count of double.
Yeah. Now it will increment it, but now it'll be less than a billionth a second, right? But as soon as that happens, the 5 numbers are available, and it just pulls them, any of them. All right. So it does now at a very, very low level. Everything is still, by the way, computers do everything sequentially. So at a very, very low level, at the level of noughts and ones, it's still doing one thing after another. All right. But Java puts them as, it practically does put them together. All right. Now at a very granular level, it's still doing one thing after another. But Java's kind of interpreting what's happening in the background and does do things at the same time. Okay. Now, so if you have everything happening at the same time, which is basically what parallel streams are all about. So parallel streams are all about everything happening at the same time. That's what it is. Okay. Parallel. If you hear about parallel processing is doing numerous things at a time. Now, so it's using all of the processors that you have on your machine to do several different things at the one time. And obviously, if you're doing several different things at the one time, it's going to be faster than doing one thing at the same time. All right. Now, so here we have our list of animals. Now, we're going to do a second one of these. So, and we're going to call this second print. Now, I am going to go animals dot parallel stream dot. I'm going to go on to the next line. And it's map. Okay. So this will go on the next line. Now, mapper takes a function. So what does it do? It takes in a string. And inside here, I am going to print off the string. And we're going to return s dot to upper case. Okay. And finally here, I'm going to have a for each. Just going to match. And all we're going to do here is we're going to got this back here. Now, if these were working in a purely sequential manner, okay? If these were working in a purely sequential manner, what happened is it would print off baboon, then the uppercase version of baboon, chimpanzee, then the uppercase of chimpanzee, anteater, then the uppercase version of anteater, giraffe, then the uppercase version of giraffe, elephant, then the uppercase version of elephant. Now, however, when you use parallel stream, watch what prints out. Okay, run it again. Anteater. Right. So each time I run it, okay, so as I run it a bit more, it gets more fragmented. Okay, so we can see, for start, there's no order to it. All right, we have anteater, giraffe, then we have uppercase giraffe, then we have elephant, chimpanzee, baboon, then we have uppercase chimpanzee, elephant, anteater, baboon. Okay, and you can also get all of your uppercases before. If you run it enough times, you will see uppercases. Now, it would mean you run it thousands of times, but you would see it happening that the uppercase would become before the lowercase. Okay,
Where's the print in the,
here,
no, the lower case or the, no,
here. Oh, the print in the lowercase inside here. Say that. Sorry, I should have explained it better. Okay, right. So this is producing parallel stream. All right. So map.
I,
Yeah.
see the first one there.
Exactly. Okay. So that's a string. So then we print off the string. Now, if it was done in a purely sequential manner, it would go baboon, uppercase baboon, chimpanzee, uppercase chimpanzee, anteater, uppercase anteater, giraffe, uppercase giraffe, elephant, uppercase giraffe. But it's not. Okay. In effect, it does all of this at the same time. And it does all of this at the same time. It produces that sort of thing. It produces lists that are all over the shop. Now, it still does what you want it to do, but it doesn't do it in the right order, right? Now, during lunch, I'll try to do a better example with dogs, okay? We'll produce a version with dogs, and what the second dog is depends on what the first dog is, okay? What the third dog is depends on what the second dog is. What the fourth dog is depends on what the third dog is. What the fifth dog is depends on what the fourth dog is. All right, so I'll show you with streams. So let's say if the first dog is male, the second dog is going to be female. All right, if you have a male and female after one another, the next dog is going to be a male. Okay, or we could do things like if the first two, if this dog and this dog are both males, then this one is going to be a female. Then that sort of thing. All right. So dogs are going to be created depending on what the dog was before it. All right. Now, they are not independent. All right. Now, yep. Yeah.
That's really that return is don't know where it really is.
No, it's just going to here. Because remember with streams. So that's that list. Changes to a parallel string. Okay. Now the product of this map is that. So it's an uppercase version of all of those. Okay. And inside here as well. Actual fact, sorry, what actually should be produced there is, if it was mapping correctly, it should print all of those in lowercase. No, actually, it should go baboon, uppercase, right? But it's not being printed in order anyway. Okay, so that produces an uppercase version of all of these, and that guy then prints it out. Yeah. Yeah, well, for each consumer, so it takes in your string. Well, yeah. Well, this guy here produces, the map produces a stream of uppercase numbers. Okay. And then for each one of those uppercase numbers, print them out. That's what it is. Okay. Now, so I'll put in a comment here. Now, as each element, could have a, let's say this. So as these is parallel streams, you have no order. So you could have uppercase versions, uppercase printing before lowercase, and vice versa in no particular order. And more often than not, the lowercase version will always print before its uppercase version, but it won't put them together in the correct. See, these are all together. All right. And if you run it enough times, as far as I know now, it would mean you'd have to run it thousands of times. You would see the uppercase appeared before the lowercase as well. Okay, it can happen. Now, so what we're trying to avoid is something called these guys. Put them here, static void ex7. So we wish to avoid stateful lambda expression. Okay, so what is this? This is where one of the results in your stream depends on a result of another element in your stream. Okay, now, so it can be another element or it can be something that's happening within the stream that changes all elements after that. Okay, so you want to avoid a stateful lambda expression. So what you ideally should have is a stateless lambda expression is where a result does not depend on any state that may change during execution of a pipeline. And what's a pipeline? Pipeline is your string. Okay. Right. Now, I don't know if I said this to you before, but you shouldn't, for instance, if you are going to add items to an array list, you should use collectors to list. Now, what to mean by this? Right, so I'll show you what I mean. So I'm going to clear all drawings. So let's just create a list and I'm going to call it int list. And it's going to be equal to, I'll put nothing in it. All right. And I am going to create a stream. iterate. So we're going to start off at 1. And we're going to unary operator. So it takes I and I multiplied by 2. I'm going to limit it to, oops, sorry. I'm going to limit it to 12. I'm going to use for each. And I'm going to add those numbers to this array list. So it's a consumer. So it takes in the I. What does it do? Now I need to put this guy up here because you can't use a, you can't, let's just see, hold on a second. Int list add I. Okay. All right. Now, so what we're doing here is I'm adding a numbers to the list. Okay, I'm adding numbers to the list. So it's going to add the numbers 2, 4, so 2, 4, sorry, it was led, I don't know what he was doing, he was making faces. 2, 4, 8, 16, 32, 64, 128, 256, 512, and so on and so forth. Okay? He was making funny symbols there. All right. Anyway, now, and I'll just go examples.ex7. Now, I'm going to print off what this list looks like. So I go int list. Okay, fine. All right. Now, it's recommended you don't do that. All right. Now, there's one very simple reason. Let me show you why. So, what do they recommend you do instead? They recommend you do this instead. You do int list is equal to where am I? Stream dot iterate 1 I is equal to I multiplied by 2 limit 12 dot collectors to list. Now, I recommend you do that instead. Okay, I have to make it a, hold on, put it outside here, because as soon as I do that, it's no longer a effectively final variable. So I'll just make it a static variable outside here. Now it'll access it fine. Now, so that will also create a perfect list. Okay, and okay, so it produces them in the order that we know of. Yeah? Right. Now, problem happens is, what if we try to do the following? Okay. If I go int list is equal to stream dot iterate. Hold on a minute now. I'll do all of this. Limit 12 dot parallel dot for each. clear int list. Get rid of everything on it. So I'm going to copy this guy up here. So stream.iterate limit now parallel. That changes it to parallel stream. Okay, that changes it to a parallel stream. So I am going to put this guy inside here. All right. Now, if I go to print off the list, it's all over the shop. See that? So what I've done there is stream.iterate.limit. Now, by using the dot parallel, that changes it into a parallel stream. Okay? It changes it to a parallel stream. Then if we use a for each, we get, it's all over the shop. Now, the highest number is still 2,948, but you can't predict the orders that are going to be in the list. They're going to be all over the shop. If I try to use a collector, so I go, it's this. And this is going to be dot PIRLLEL dot collect collectors to list. And then if I go to print off this list, okay, right? Now, that works, okay? So you can see that when you have parallel processing going on, right? And you're using a for each, they're going to be all over the place. That's why they recommend you do this instead, all right? So it's better for you to add, to do something like this than to do something like this. Okay, so this guy will enter numbers in order. This will also enter numbers in order. No order to how lists or to how numbers are entered. And now there is an order to how lists or how numbers are entered. Now, there is an order, but you're not guaranteed with this particular version that they are going to be entered in the correct way. All right. There is a particular specific collect method for parallel streams. Okay. This does not guarantee correct order always. There is a specific collect. There's a specific overloaded collect method that you should use with parallel streams. Okay, now in the majority of cases, probably 70% of cases, it still will work correctly, but it's a 30% where it doesn't work. Yeah, probably around 30%. So now we're going to build up to this because we have to do a couple of other steps before we show you this method. Now, this is all about dealing with parallel streams. All right. So I am going to do another list here. Okay. Now, I am going to do, first of all, I'm going to create a synchronized list. Now, this is the synchronized list I prefer to use. I can't remember why I use this one, but what I'm going to do. So list integer data is equal to collections dot synchronized collection new array list. Now, what that does is that is a thread. Why is that? Should be. See, should work. All right. Now, that is quite simply a synchronized array list. Okay, it's thread safe, which means only one object can access this list at a time. All right. Now, I'm going to use a parallel stream with this. Of course, if you did something like this, that means you lose all the benefits of a parallel stream. Do you understand that? Yeah. If you do something like this, you do lose all the benefits of a parallel stream. That's the first thing to remember. So this is a thread safe. This is a thread safe array list. So you effectively lose benefits of parallel streams when you use this collection object. Now, so I'm going to create an arrays as list here. Okay, so I'll create another list down here. It's going to be integer, and I'm going to call this numbers is equal to new array list. Now, the reason I keep doing this is because, remember, if you just go list numbers is equal to arrays as lists, that's going to be a list where you can't add in numbers. If you do it this way, you can add numbers to it. Okay, so arrays as list, I'm just going to put in the numbers 1, 2, 3, 4, 5, 6. All right, now I'm going to use this as a basis for my streams. So what I want to do is I am going to add right. So I'm going to add each one of these numbers into this list. Okay. Now, so we're going to see what happens. And we're going to use a map to do this. Okay. So I go numbers dot parallel stream. Now, by the way, by going numbers dot parallel stream, that changes it to a parallel stream. This guy does the same thing. Okay. Now, that can only be used after some operation has been done on the numbers. As far as I know, you can't go numbers dot parallel. Do you understand that? So that parallel can only be used after some intermediate operation has happened. Okay, so an intermediate operation has to happen first before dot parallel can be used. All right, now, so you have to go dot parallel stream. Now, as soon as you go parallel stream, you could go dot parallel. That wouldn't make sense to do that because that's just saying it's a parallel stream. It's a parallel stream. All right, so we make it into a parallel stream. And I'm going to use a dot map. Fuck off. Oh, go away. Now we're going to put this on a separate line because this is a bit lengthy. Okay, so map. It takes in the number. All right. And what it does inside the map is going to do two things. Okay. First of all, it's going to add it to the collection, to the list called data. So data.add I, which is this guy up here. So adding it to the slide up here. And what it's going to do is it's going to return the same number. All right. So what happens in the map? It takes in the number, it adds that number to this array list, and it returns the same number. All right. If you want to do something with the number, if you want to do something with an element in the middle of a stream, what you should use is map, by the way. Okay, not the for each. If you want to do something in the middle of a stream, now because if you use a for each is the last thing you can do. A map is in the middle of a stream. You can put in another map after it if you want to. Okay, so if you want to do something to your data in the middle of a stream, you use map. Sorry? Sorry?
If you have an inner stream, that's okay.
An inner stream.
Yeah.
Oh, you can.
Inside that.
Yeah, you can. Yeah. Yeah, you can have streams and side streams. It's an intermediate operation. Yeah. Exactly. So you can have as many maps as you want. You could do a map, do a limit, do a filter, and do a map on that. Okay. That's the beauty of streams. They're like Lego blocks. You build a bit. Okay. And also, there's one other thing. Just to go back to threads. A small thing again, right? Now, human beings, we do good. We're good at doing things one after another. All right. Multitasking is not our suit. All right. So if you have multiple threads, and multiple threads are going to be doing tasks, make sure you focus on one task at a time you're doing in your coding. All right. If you have 4 threads, you focus on one thread and you do a task. Then you focus on the second thread, you do a task. Then you focus on the 3 threads, you do a task. Then you focus on the 4th thread, you do a task. Don't be trying to do a task across all 4 threads at one time, because you're not going to be able to do it. All right. So how you manage your work is very important as well. All right. And focus on one thing at a time. All right. Now, that can be difficult enough when you're doing threads, but you should, when we're doing streams, you focus on the map when you're doing the map. Then you do the next part. Filtering, focus on the filtering. Then you focus on the limiting. Then you focus on the for each. All right, you do one thing at a time. That's one good thing about streams, is that they force you to focus on one thing at a time. It's very easy trying to do 10 different things at the one time in software development. All right, so that, yeah.
In that map then, that you're returning I, because the map always expects to return.
Well, no, a map takes a function. Okay, so it takes in an object and it returns an object. It doesn't have to be the same data type. It can be a different data type. Or no, sorry, a map takes a function. Yeah, it does take a function. This function takes in an integer and returns an integer. It doesn't have to return an integer, but it has to take in an object.
It has to return something.
Yeah.
That's why return I is there.
Yeah. 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 Well, the reason return I is there because we've more than one line of code inside this. See here? If we had only one line of code, then you don't need to return. All right. So now what's happening inside this is that it's going to add a number to this guy up here. Okay. Now, as it's a parallel stream, I'm going to use for each ordered. Now, this is going to display our results in an ordered fashion. So it's going to display 1, 2, 3, 4, 5, 6. All right. So what do we got to put in here? For each ordered is I'm going to go I want it to display it like it does when it's an array list. So I'm going to say I plus and a space after it. All right. And I close it off. Hold on a minute now. I don't see the wrong there. Oh yeah, what the fuck am I doing? Sorry about that. So it's SYSO, and we go ah. Now, so if I print this guy out, it looks like everything is okay. It looks like it's, yeah, it's printed out stuff in the correct way. All right, and that should be print. So it's 1, 2, 3, 4, 5, 6, right? So it looks like, now, thing is, this is only going to print them out in the correct order. If we have a look at our list, okay, which is this guy up here. So if we print off data, it should be on the next line. We can see that it's all over the shop. All right. So now that's the case when we're using, so here we have got a synchronized list. Okay. So when you're using a synchronized list and a parallel stream, you're guaranteed that all of your numbers in this case will be entered. But you can't guarantee the order. Okay. So with a parallel stream and a synchronized list, you are guaranteed that all the numbers will be entered, but not the order. Okay, so now here's the thing. Do all your lists need to be in order? No. The vast majority of lists, sets, queues, whatever, don't have to be in order, right? That's what databases are for. You can bung them into a database and the database will order them for you. And that's what databases are good for. So this isn't a terrible solution, all right? So if you use collection objects that are synchronized with a parallel stream, you're guaranteed that all of the items will be entered, but not the order. Now, if you use a non-synchronized list, wait till see what happens. All right. So I am going to go. So this is a synchronized list. Using synchronized list with using a synchronized list with parallel streams. Okay, so this is using a non-synchronized list with parallel streams. Now I'll have to run this 10 or 12 times for you to see what should be happening. Now, just before I go on to the next one, this guy here, this is a stateful lambda expression. Now, a stateful can mean anything that changes over a state is something that can change over a lifetime of a stream. I changes each time. So for each number on the list, it changes. Okay, so that changes. So that number depends on what stage you are in this guy. Okay, so that number there, so it's 1, 2, 3, 4, 5, 6. So that changes depending on what position you are in the particular list. If you're at the first item of the list, it's going to be 1. If you're at the second item of the list, it's going to be 3. The thing is, it could skip to 5. It could go to 6. It could go to 4. It could go to 3. Okay, so it changes depending on that guy. All right, that's a stateful lambda expression, and you should try and avoid stateful lambda expressions. In actual fact, the recommendation is that you avoid stateful lambda expressions in both parallel and non-parallel streams. That's the recommendation, but you definitely should avoid them with parallel streams. Okay, now, not guarantee the order, but the real issue happens when you start using this guy with a non-synchronized list. So I have, yep.
Can you just say that again about the stateful lambda expression, about the I change?
Right.
So you got numbers written before.
Right. I'll put in a comment here about this. So the values entered in the data synchronized list depend on what value I is at a particular point in the life cycle of the stream pipeline. Okay. Sorry, the values entered in data in the data synchronized depend on what value I is at a particular point. Now it's not in the life cycle stream. So it goes to the first one, it goes to the second one, it goes to the third one. Do you understand what I'm saying? So how do I put that in English? Values into the data synchronized depend on what value I is at a particular point. See, it's not in time, because in time it could be at the 5th. Yeah, so values into the data depend on what value I is at a particular point in time. i.e., first element is 1, second element is 2, third element is 3, fourth element is 4, fifth element is 6, is 5, sixth element is 6. So the values that go in here depend on what value is at a particular position in the numbers list. Okay, so what happens here depends on the state of this guy here. Okay, so what happens in the map depends. So what number is entered in the map? What number is entered into data list is dependent on the state of the numbers list, whether it's, if it's at the first element, if it's at the first element, it will insert number 1, second, number 2, and so forth. Okay, so this guy here is dependent on the state of another element of the string. Okay, it's dependent on the numbers. So what position it is at. So whatever position it is at, that's what it's going to be entered in here. And as it's a parallel stream, you can never know which number it's going to be. Okay, so as it's a parallel stream, you can never know for sure which of the 6 numbers it will be, as all numbers process at the same time. Numbers, if threads are available, will be processed at the same time. All right. Now it is recommended. So remove stateful operations when using parallel streams, and also, if possible, are serial streams. Okay, so that's why they say not to use a for each to insert something into a list. Don't use a map for inserting. Now, so you should be using the collection for a map rather than using the add inside here. Okay, now, so here you're not guaranteed order, but there is a worse thing that can happen to you. All right, so I am going to create a new list. Okay, I'm going to call this list. It's going to be an integer. It's going to be called data2. It's going to be called new array list. Now this is not synchronized. Okay, this is not synchronized. So we are going to do the exact same as above, except we're going to add it to data2. So I'm going to take this. And I'm going to use this. I'm going to add it to data2. Right. So I am going to insert, so just bear with me a minute now. And this is going to be data2. Right, so now this guy is going to show them in the order, but this is going to show they're unordered. All right, Now, it'll probably take 10 or 12 to show how this actually happens. So I'll run it once. All right. Woohoo, what happened there? Now, let's try it again. So I've got a null 4, 6, 2, 5, 3. All right. Even though it's saying 1, 2, 3, 4, 5, 6. And yet here I'm getting null 4, 6, 2, 5, 3. All right, again. Now I'm only getting 4 numbers. Sometimes I might get 6 numbers. Run it a few times more. Run it again. Oh, there's 4 again. 6, run it a few times. Now, as you've less threads, you should be getting less numbers more often. Try and get to 4 again. Come on. Right, now I've got 2 nulls and 4 numbers. Right? Now, what's actually being produced by the stream is 1, 2, 3, 4, 5, 6. The problem is this guy. Okay? So it is producing the correct numbers. All right? However, this is what's causing the problem. All right? So this guy is producing the correct numbers. So if I had to collect dot collectors to list, it would save them all to the list. Okay? Do we understand that? Yes? So the problem is this guy. All right? Now, first of all, data 2 is a non-synchronized list. And that means that multiple threads can attempt to put in a number at the same time. Okay? So, right, let's get this right. Now, if you remember, now I'll just ignore the nulls for a minute, if that's okay, because it's easier to explain if there's 4 numbers in it. All right? So, 1, 3, 6, 5 has been produced. Yes? You'd seen it that it was only producing 4 numbers, right? Yeah? Yes? Right. Now, thing is, this stream is producing 6 numbers. So where are our 2 numbers gone? So the numbers are, what's missing is 2 and 4. Now, obviously, that's a catastrophic thing to happen in computer programming. All right? You're expecting 6 numbers, you get 4. So that's not acceptable. Now, what's actually happening is the following. Now, if you remember that behind an array list is an array. Now, what's happening is, so 2 and 4. So we'll say 2 and 3. Okay, so 2 is missing. What happens is that at the same time, there's an array in the background. All right, there's an array in the background. Now, it attempts to add. Now, an array is not thread safe either, by the way. All right, an array is not thread safe either. So what happens is it attempts to add 2 and 3 to the second position in the array at the same time. Okay? And when you have that sort of situation with threads, what happens is it picks one. Now, it's usually random the way it picks it. It's usually eeny, meeny, miny, mo. All right? So if you have 2 threads accessing an array and they're both trying to put in the same element at the same time, it'll only put in one of them. If you ran that enough times, you'll see it's only given 3 numbers. So it's attempting to put, so remember that so it starts off with 1 in our array. Okay, so we're an array list, so in the background array has just got the number 1 in it. It next tries to put 2, that thread tries to put 2 into the second position, but at the same time, it tries to put in, another thread tries to put in 3. Okay, if you try to put in 2 numbers into an array at the same time, one of them is lost. It's just one of them is picked. So which does it do? Now, I think as far as I know, it usually picks the higher number. Usually. So we get 1, 3. No, it doesn't usually pick, it didn't pick the higher number there in that case, all right? So I don't know what algorithm it uses to pick the number. But 2 and 4 are gone. All right? So that's another example of a stateful lambda expression. Now that's a lot more serious. In the previous version, you just had order to contend with. With here, you have a loss of data. And no matter what your program should do, it should never lose data. Is that okay? So this is the first problem with, now you're supposed to avoid stateful lambda expressions in serial streams. Serial streams is one after another. You're supposed to avoid them in both. All right, but it's more important you avoid them in parallel streams. And what is a stateful lambda expression? It's a lambda that's dependent on some other state of some other part of the stream. In this case, numbers. They should be all independent of one another. All right. Do you remember the builder pattern? Remember that thing? Jesus, I've nearly forgotten it myself. Mind you. Fuck's sake. It seems like decades ago. Okay. The beauty of the builder pattern is that every item is totally independent of each other. Streams have the same process. Each one of these guys, parallel streams, should be independent of map, which should be independent of for each ordered. All right. That's what an independent operation means, is that each one of them should be independent of each other. It's not so much the things they produce, it's that all of the operations are going to be independent. All right. So you have numbers, then you have a parallel stream that does its thing. You have a map, it does its thing. It's going to produce a number. Okay. That number is going to be acted upon in here. But everything is independent, is the best way to describe it. Yeah.
Sorry, no, just keep on here.
I don't know what I was going to say.
I was going to say what you got for each order. You would just for each there.
All of right. So you can see I do for each ordered. So you'll this is the so what you do, that puts an order on them. Yeah. Okay. If I just put in for each. Now, for each is going to be the way they're inserted into the. So if I do for each, they're going to be the same. See? Because that's the order they're entered into the list. Now you have to run it a few times before you see forward. There's 5 there. There's 6 there. 6 there. 6 there, 4 there, 6 there, 6 there, 6 there, 6 there, 6, 6, 4, 5. Okay. Now, if it was a case that every 4th one produces 5, that's not a problem because that's predictable. What's happening here is inherently unpredictable. Okay. So for each ordered, so I'm going to put in a fairly long comment here. So we are using a non-synchronized collection type array list. So results can be lost. Okay. As we can see, for each ordered, let me just see this. Produces always 6 numbers. Now, however, the issue is with the stateful lambda expression data 2.add I. Okay, as when using an array list, the JVM, which is the Java virtual machine, manages a primitive array of the same size. So as elements are added to the array list, background array is increased in size. But if 2 elements are added to the same position at the same time, only one will be added and the other lost. Now, this stream still produces the 6 numbers. So it produces the right 6 numbers, but the problem is this guy. Okay. Now you could use a for each ordered and have data 2.add inside there. But again, you wouldn't have order, and it can lead to loss of numbers. So the main issue with stateful lambda expressions in the likes of a collection is you can lose values, which is very serious. And you can't predict when it's going to lose the values either. That's the problem. If you could predict when it was going to use the values, then that wouldn't be a problem. If let's say it was going to only have 4 numbers every 5 times, that's a prediction. You know what's going to happen, but you don't. You could run it 1,000 times and it'll run fine. You could run it 5 times in a row and none of those 5 times could be 1. All right, so watch me go again. You see, when we use for each ordered, this will print off in the right order, which proves that this stream is producing the correct numbers. Okay. However, this is the problem. So I'll run it again. 6 numbers are added. 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 Go a few more times. Only 4 numbers are added. Now I'm not 100% sure why a null is being produced there. Okay. But a null is the same as nothing. You can't do anything with a null either. There's only 4 numbers that have been added there. All right. So this might add 6 numbers, might add 5 numbers, might add 4 or less numbers. In extreme circumstances, it might only add 1 number. Yeah, that's possible.
I had 4 nulls.
Huh?
I have 4 no's.
Yeah, I don't know why it's not. I presume it's just something going on there. But it's the same principle. Okay? Might add 4 or less numbers. The key here is that it's not predictable how many numbers will be added at any one time. So it's fairly important that we avoid these sort of guys. All right. Now, you should really avoid them as well when you're dealing with serial streams. All right. If you remember before when we were adding stuff to an array list, we saw sometimes it just adds them all over the place. All right. So the rest of this section is going to be about avoiding these lets. All right. And using various techniques to avoid these stateful lambda expressions. And the main thing we're going to be doing is we're going to be using overloaded. So this is all about stream operations. Okay, it's all about parallel stream operations. And so we're going to be using something like find any, find all, skip. What else do we have? We have now reductions, reduce. Reduce is difficult. Jesus Christ. Yeah, but see, this is using them with parallel streams. We didn't do them with parallel streams. Remember other time we were saying we won't do parallel streams. All right. So collect is, yeah, okay enough. Now the most difficult one is reduce. Yeah.
Do you run into issues there with arrays or array lists where if you have more than 10, it creates another problem?
Well, when it goes over 12.
Is it 12?
Yeah, isn't it 12?
Yeah.
10. Okay, because what's happening?
Could that be an issue there now? Is a further issue?
Not really, no. No, not really. I'd imagine, Kieran. I don't know, but I don't see how it would. It's just another thing. Now, actually, I did come across something before where I was using a parallel stream, and I'd say it's obviously done. And I was doing something like this, and I kept getting array index out of bounds exception. So I'm guessing it was something to do with that. All right. Now, parallel streams, yes, they're very efficient, but there's a bit of a learning curve in them. And also, you want to make sure you know what you're doing. So if you have some sort of process that's running very slow, right? Let's say you're processing and you're using streams and you're using normal streams and it's taking forever to do anything. Consider at that point using a parallel stream. But make sure you have a non-parallel stream version as well that you can test it against. Right? If your non-parallel stream version is working perfectly, you then do a parallel stream version, and you should be getting the same result. Do you understand that? And maybe even have a loop, no matter how complicated it is, and you know the loop works. Make sure you're getting the same answers. All right. Now, so I'm not going to start the next part yet because it's a big section. So just chill out for the next 4 minutes and then you can go for your lunch. All right, so I'll start.